guys, welcome back. So what we're looking at today are lessons 2 and 3. Lesson 2 is exploring circles and lesson 3 is exploring circumference. So a lot to do with circles today. So let's go ahead and get started. So sorting round objects. I have a document that we're going to look at that has round objects on it. And with that, we're going to take and determine how we could sort the pictures into two groups. So give me just a second to get that up. So here we have some of our round objects. So we've got the fan cover, a wagon wheel, the utility hole cover, airplane propeller, bike wheel, glow necklace, got the yo-yo trick, dartboard, grill, all these different things, center pivot irrigation, boiled egg, basketball, clock, rug, ladder, pizza, speedometer, and an orange slice. So looking at all of these things, what could be two groups that we could split these up into? So hopefully you're thinking maybe circular versus non-circular. So circular versus non-circle. So some of these are perfect circles, others are not quite so much. So we could take and work on sorting them. So the fan cover, would we say that it's a perfect circle? Yes. What about the wagon wheel? Yep. Utility hole cover. The airplane propeller. What about the bike wheel? And the glow necklace. So a lot of these are all perfect circles. The yo-yo trick, dartboard, grill, irrigation. The boiled egg is not, though, because look, it's not perfectly circular if we're looking at the actual egg. If we're looking at the yolk, then it's closer to being a perfect circle, but not. What about the basketball? So looking at it as a two-dimensional figure, it looks perfectly circular, but it's really three-dimensional. So not circular. What about the clock? Definitely not. It's a 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. Not even a regular octagon at that. What about the rug? Nope, it's definitely more of an oval. What about the platter? Also pretty oval looking. The pizza? Well, it's missing a slice, so can we really count it as a perfect circle? Nope. How about the speedometer? Be careful with this one. Nope, it's not, because notice, it may be perfectly circular all the way around there, but it's got this flat side down here. Can a circle have a flat side? Nope. And then what about the orange slice? Yes. Yes, indeed. Okay. So based on all of that, what are some of the characteristics that all of the circles had in common? So what did we notice about all of the ones that were circles? What they have in common with each other? So they were all round. They all, what? Did they have any flat surfaces? No, so no edges. No vertices, because none of the ones that were round or circles had any points. And vertices are where two sides meet, so no vertices. What else? What else do we know about circles? So they equal 360 degrees. So they have 360 degrees to them. They have lines of symmetry. So we could see that on the wagon wheel and on the bike wheel and on the orange slice even. We could see the lines of symmetry in there. So lines of symmetry. What else? What else do we know about these circles? Why wasn't the pizza considered a perfect circle? because it was missing a piece, right? So it has to be what's known as a closed plane. That means that it's a complete circle. There's no gaps. There's no missing pieces out of it. We also know, hopefully you remember, diameter and radius. So all the diameters should be equal, all the radii should be equal in a circle. That makes it a circle because that will make it perfectly round. So diameter and radius need to be equal, each of them. So all the diameters in a circle need to be equal, and all the radiuses need to be equal. Diameters and radiuses should not be equal. All right, so we aren't going to put the objects in order from smallest to largest simply because that's a little hard with it being online versus having it there in front of us to sort out in front and move around. So for number 5, though, select one of the pictures of a circular object. What are some ways we can measure the actual size of our circle? So think about, let's look back at one of these pictures. Think about the glow necklace. How would we be able to take and measure this glow necklace? How could we do that? Well, we could use so I'm more asking in this case, thinking of what things can we measure in the circle rather than how can we actually do it. Obviously, we're going to use a ruler or a tape measure or something like that to measure it. But if we think about it as what part of the circle are we actually going to measure, well, we have the diameter. So all the way across the circle. We have the radius, because we've already talked about these two things. And remember, radius goes from the centermost point to the edge of the circle. And then the last thing is the circumference, so all the way around. So we could also, once again, I don't know what this is doing with the strange lines. Do circumference. So that would be the distance around the circle. So if we were to walk around which obviously a glow necklace we're not going to walk around, but thinking about going all the way around it and covering it, how far would that be if we stretched it out to see it physically? So that is what we are looking at there. Now, the next thing we're looking at, measuring circles. Priya, Han, and Mai each measured one of the circular objects from earlier. Priya says that the bike wheel is 24 inches. Han says that the yo-yo trick is 24 inches. And Mai says that the glow necklace is 24 inches. Do you think that all these circles are the same size? So if we think about it, a bicycle wheel and a glow necklace, do you think they're actually the same size? They're both 24 inches? No. No, they're definitely not the same. What are they doing? They're measuring different parts of the circle. So one of them might be measuring the diameter, another's doing the radius, and another is doing the circumference. So now what we need to do is figure out which one each of them was actually measuring. So the bike wheel is 24 inches. Do we think that's the radius? So halfway across the bike wheel? So the bike wheel full height would be 48 inches. Do we think that's true? No, probably not. That'd be a really big bike wheel. What about the circumference? Do you think it's 24 around? Or do you think it's 24 across? Like from top to bottom, the height of that bike wheel would be 24. Hopefully, you're thinking that it would be the height of it or the distance across. So it'd be diameter for the first one. The bike wheel has 24-inch diameter. Now the yo-yo trick is 24 inches. Now remember that yo-yo trick, he's taking and spinning it, and it's a big circle. So do you think it's the circumference is only 24 inches? Or the radius is 24 inches? It's the radius, because then it would be double for the full thing. So the diameter would end up being 48, which is quite large, which would fit with how big that yo-yo trick looked. And then Mai says the glow necklace is 24 inches. Most necklaces are 24 inches. There's a lot of them that have a 24 inch. and that's circumference. It's the distance all the way around. So circumference. So being able to recognize these different parts and what they might be measuring, but can still be getting all the same value, knowing there's different parts of a circle to measure. So keep that in mind as you're taking and doing these, okay? All right, now we're going to take a look at lesson 3. So on lesson 3, like I said, it was looking at circumference, so going into more depth with our circumference. So coins, cookies, and drinking glasses are some examples of common circular objects. Explore the applet to find the diameter and circumference of 3 circular objects to the nearest tenth of a unit. Record your measurements. So here we have some circle. We're going to unroll it. It's got a diameter of 4.5. And we're going to unroll this. So the diameter was 4.5. And now if we look, this is 14. Oh, I don't know what my screen's doing. We're at about 14 for that. So 4.5 and 14. Bless me, sorry. Okay, now let's try another one. Refresh it. So let's do a bigger diameter. So let's do 8. We unroll this. Maybe we can see where it ends up at. It's going to end up all the way over here at about 25. So 8. I don't know what my computer is doing today. And 25. And now let's go for one that's a bit smaller. Unrolled. Let's go for a nice diameter of 3. All right, so if we unroll this, so we end up at about 9.5 for this. Now, obviously, I am doing estimates on this. I am not doing exact values because we are trying to measure these. So there is always room for some error when we take and do these. So keep that in mind when we're taking and looking at these. There is room for error in all of these. So now it should graph it, but it doesn't look like it's going to. Okay, so 4.5 and 14. Be right about there. We've got 8 and 25. And we have 3 and 9.5. So what do we notice? The relationship between our radius and our circumference appears to be in a line. So it looks as though we have a line here that it's forming. Obviously, there's some sort of constant value that we're multiplying by each time in each case. So for finding circumference, I'm going to tell you guys, finding circumference is using, it's in the form C equals K times D, where K is a constant, C represents the circumference, and D is the diameter. So this is the diameter. This is our circumference. And this is some constant. Which, looking back at that, would be about 3.1. Now, in actual terms of circumference, it's pi. We'll talk more about pi later. But what we're going to use as our constant is about 3.5.